Hi, welcome to the studio. So today I want to try a different kind of video. I want to make a movie prop. So the movie Ghostbusters is coming out in a couple weeks, and what I want to try to do is have a prop ready for about that time. So the prop that I want to make is a ghost trap from the original movie from the 80s. So what I have in here are just a couple things I didn't happen to have in the shop. For the most part, I just want to use scraps. I don't want to go through making everything perfectly intricate. I know there are people out there that love all those little things. Adam Savage is one, where they know the exact measurements of all the individual screws, how far apart they are from one another. So to make it as screen accurate as possible, we're not doing that here at all. This is more of an artist representation, and it's something that if they saw it on the shelf, they would know exactly what it is. But once you break out the calipers, this isn't going to match up. So today we're just going to focus on the special effects, and this is what I had to have. That's what I had to buy here that I didn't have on hand. So in here, I have some lights that'll come out of the device itself. These are from a ATV. I have lasers that we're going to try to do some cool effects with motors and speed controls and such. I have a smoke emitter, which is really just a humidifier, but we're going to modify it to work for our benefit. And then I have some fans that we can move around the smoke and then push the lights through. So for this first iteration, all I want to do, for this first video, all I want to do is make just the special effects. We're not going to worry about the case itself at all. I really just want to get the special effects, have the smoke, have the lights, have the lasers, and have a really cool effect before we even start on the case. So let's try some things or see what we can get going. The basis of what we are working on for the video of this project is focused on volumetric light, or light beams as it's sometimes called. This is a naturally occurring effect that we see in daily life. You may have seen it in buildings in the early morning, like here in Grand Central Station. It's also used as a feature in the Luxor Hotel in Las Vegas, shooting a beam of light into the sky. And sometimes you even see birds that look like sparkles when they fly through it. As an example, imagine a car's headlights on a foggy day. If someone was to place their hand on the beam, you would see the shape of the hand projected in the light. I'm going to attempt the same idea, but rotating the concept, pointing it straight up to emit light from a ghost trap. Instead of shadows, I plan to use multiple light sources, including fog lamps and lasers. The difference for me in this project is that I will need to create the environment along with the lighting. Let's get started. I put the mist maker in an old container to see how the manufacturer intended for it to be used. We can destroy the warranty later. The mist sits in the bowl because much of it is heavier than air. We will need to disperse the vapor by simply blowing it out of the bowl. Adding a fan and a bit of direction with this straw helps channel the mist. Let's build another temporary container that shoots the vapor up, and we will add an additional mister for even more of a smoke effect. This is styrene that I buy in large sheets for some of my projects. I am using a solvent to actually melt it together versus using glue as an adhesive. Adding some waterproof lighting will enhance the volume of the mist, as much of it is near invisible to your eye. Well, I think we can call that a success. I think it's time to play with some lasers. I'm gathering some components in my studio to put a working model together. The concept is that I need something to move the laser beam through smoke that we now have and bounce some of that off of the vapor particles. In movie production, they would generally use CGI or careful mirror placement to trick the eye. I would really like to have people see this firsthand and have it as a practical effect. It might just be possible to overplan things sometimes. With many years of working with model planes, helicopters, and quad racers, one might get brushless motors, electronic speed controls, solder them together, cutting, drilling, and sanding a trapezoid to fit on a motor, adding reflective tape, and then add an additional power supply. But we're not going to waste an hour and a half doing that here. Let's just glue two tiny mirrors to a small fan and call it a day. Nice, we're making progress here. For this simple bench test, this is a breadboard that mainly has voltage regulation and a relay. This is a Christmas light projector, and the laser prism that we assembled with tiny mirrors earlier. I am connecting two 11.1 volt batteries in series to get the 22.2 to 24 volts needed for the humidifier. Speaking of that, this is the next test version of the humidifier test chamber. This is sealed, other than the hole for the fan. For this proof of concept, once I press the small button on the board grounding all the components, they all turn on. In the final product, these will turn on at different times, but I'm pretty excited to see where this is going. Let's get a quick overview of what's going on here for the electronics. Here are our batteries connected in series, connecting the positive from one to the negative of the other. The remaining leads are used for the power, giving us 24 volts to the system. We have voltage regulators used to transform the 12 volts to 5 for our fans and projector. There's a variable 3.5 volt regulator for the laser pointer. There are 2 relays used to power the components using higher current, like lights in the humidifier. Now I want to control all of these at various times. So we're going to use an Arduino controller. Don't be intimidated, they're not all that complicated. The teaching kits tend to be larger as they may have much more capability, but we're going to use one of the simpler ones. An Arduino at a fundamental level follows a set of simple instructions. For instance, once I turn a switch, I may want this to turn lights on, open a door, start the smoke, wait 5 seconds, engage the laser, and turn the fans on to move the smoke. And maybe when I turn this off, I might want it to do everything in reverse. I would have another set of instructions for that. The idea is that I can change or adjust at any time without changing any physical electronics, only code. It might be geeky, but it's taking this project to another level. After building all the test models, we simply played and tried to come up with tons of various ideas and combinations for days. The kids and I may have had a little too much fun with this. I'd like to make some of these options in the final model, though time will tell and they can all be programmed in the future. Anyway, we're ready to wrap up this video and start on the next parts. I really hope you enjoyed this as much as we did. From the hours and hours of various experiments we've tried, I believe we achieved some pretty interesting effects here. Setting the timing for things to turn off or on can even add to the feel of what we're seeing. Let me turn off the directional fan so it looks like the light is receding back into the trap. I love where this is going. Next, we will build the actual trap for this effect. I hope to see you there. Thanks for watching. I appreciate your time. Let's see that again.